Have you ever stared at a Bitcoin address, that crazy long string of letters and numbers, and just wondered what is going on there? Well, I can tell you it's not random at all. Today, we're going to peel back the layers and uncover the cryptographic magic that makes the whole thing tick.
The whole system really starts by trying to solve one massive puzzle. How in the world do you pay someone on a network that's completely public, where anybody can see every transaction, but still keep things private and secure?
So to figure this out, let's bring in our classic crypto duo, Alice and Bob. It's a simple scenario. Alice wants to send some Bitcoin to Bob, but the real trick, the whole point, is to do it in a way that only Bob can ever access or spend those funds.
And that right there, that's Bitcoin's private payment puzzle. How do you get secure private payments on a ledger that is, by design, completely public? It sounds like a total contradiction, right? But the solution is unbelievably clever.
And that solution, it all starts with a really simple idea you can think of as a secret and a lock. This is the heart of what's called public key cryptography, and it's the foundation for pretty much all of our modern digital security.
The secret is your private key. And here's the wildest part. A private key isn't some complex encrypted file. It's just a number. That's it. A really, really big number that's picked at random. This single number is the only thing you ever have to hide.
And when I say a really big number, I mean, it's hard to even put into words. Your private key is chosen from a range of 2 to the power of 256 possibilities. That's a number so huge, our brains just aren't built to comprehend it.
To try and put it in perspective, this quote really nails it. The number of possible private keys is around 10 to the power of 77. For comparison, scientists think there are only about 10 to the power of 80 atoms in the entire known universe. So yeah, guessing a private key, it is just not going to happen.
Okay, so if the private key is your secret, then the public key is the lock. It's a different number that's mathematically linked to your secret, and you can share it with absolutely anyone. People use your public key to send you Bitcoin, basically putting it in a box that only your secret private key can unlock.
The magic that connects these two is what's called a mathematical trapdoor. It's a one-way street. Using some seriously advanced math called elliptic curve cryptography, it's super easy to calculate a public key from a private key. But trying to go the other way, to figure out the secret from the lock, it's basically impossible.
Okay, so we've got our secret key and our public lock. We understand the math, but how do we get from all that theory to a usable address that you can actually copy and paste into a wallet? Well, that's the next part of the journey.
Right off the bat, we have a problem. A raw public key is just a monster. It's over 100 characters long. Can you imagine trying to read that over the phone or type it out without a mistake? It's totally impractical and just asking for errors.
The solution starts with a process called cryptographic hashing. The easiest way to think about a hash is like a machine that creates a unique digital fingerprint. You can feed it any amount of data, in this case our super long public key, and it spits out a short, unique fingerprint that's always the same length. Now here's a crucial detail. Bitcoin doesn't just hash the key once. It's actually a two-step process. First, that long public key gets run through the SHA-256 hash function. Then, the result of that gets immediately run through a second, different hash function called RIPMD160. This double hashing gives us a much shorter, much more manageable public key hash.
So this is way better. It's much shorter, but it's still just a raw string of characters. If you make a single typo trying to copy this, your money could be lost for good. We have to find a way to make it basically error-proof for humans.
This is where the final clever bit of encoding happens. First, a version byte is stuck on the front of the hash. This just tells wallets what kind of address it is. Then, that whole new string is hashed twice to create a checksum, which is just a little tag for checking errors. The first few characters of that checksum get tacked on to the very end. And, finally, the whole shebang is encoded using a system called Base 58.
And boom! What do you get after all that? You get the classic legacy Bitcoin address that so many of us recognize, the one that almost always starts with the number 1. Every single part of that string is there for a reason, all designed for security and usability.
But of course, technology never just stands still. That legacy format was brilliant, but it wasn't perfect. And that's why the next stage in this evolution was all about making these addresses even smarter.
Just take a look at the leap from the old legacy format to the modern BC32 format. The improvements are all about making life easier and safer for the user.
See how the modern BC1 addresses are lowercase only? No more trying to figure out if that's an uppercase I or a lowercase l, and the error checking isn't just better, it's a whole lot smarter.
So let's just run through why this is such a game changer. Being lowercase only is a massive win for readability. The error detection is so good it can often tell you exactly where your typo is. And because it uses a simpler set of characters, the QR codes it generates are smaller and way easier for your phone to scan.
And the innovation didn't even stop there. Developers later discovered a tiny, really subtle bug in the first BEC32 standard and fixed it with an update called BEC32M. This just shows you how the community is constantly refining and hardening the network to keep it secure for the future.
So, we've gone through all this cryptography, all this encoding. What's the big picture here? Why does the format of a simple address actually matter so much? Okay, let's boil it down to the absolute must-know takeaways. First, your private key is your Bitcoin. It is the one and only thing that truly matters, the ultimate secret. Second, public keys are just the locks that let you receive money safely without giving away that secret. And finally, the address you see, that's just the user-friendly, error-proofed version of the lock, built for privacy and real-world use.
When you really get down to it, a simple Bitcoin address is nothing more than the visible tip of a massive, elegant cryptographic iceberg. Underneath that one little string of characters is this incredible foundation of math that keeps the entire network secure.
You know, seeing all the complexity that's hidden inside something as ordinary as a Bitcoin address, it really makes you wonder what other incredible secrets are hiding in plain sight in the technology that we use every single day.